NASA has confirmed that the mysterious object known as 3Y Atlas has shifted course, and the implications are staggering. Early reports hinted that this interstellar visitor might not be a natural body at all. The most striking image revealed something that left astronomers speechless. Instead of a cometary tail stretching away from the sun, Atlas displayed a cigar-shaped glow pointing toward it. The object was nearly 10 times longer than it was wide, with an eerie luminescence, more like an engine flare than the diffused spray of dust we expect from comets. The enigma only deepened when chemical analysis revealed a cloud of gas composed primarily of carbon dioxide, accompanied by streams of atomic nickel, but without iron. In nature, nickel and iron are almost inseparable, forming together under similar stellar conditions. Finding one without the other is virtually impossible outside of controlled industrial processes. The discovery raised an unsettling possibility. What if this object was built, not born? Astronomers first registered the anomaly on July 1 when observatories in Chile tracked an object racing toward the inner solar system at over 130,000 miles per hour. At first, researchers suspected equipment failure, but when recalibrations and independent observations confirmed the data, they realized they were seeing something extraordinary. The Atlas survey team quickly designated it 3 Atlas, marking it as only the third confirmed interstellar visitor in human history. Yet, unlike its predecessors, Oumuamua in 2017 and Boris in 2019, this one was breaking every rule in the cosmic playbook. Instead of drifting through space on a hyperbolic path, 3 Atlas appeared to be moving with deliberate precision. Its eccentricity value exceeded 6, making it the most extreme trajectory ever recorded. But the real shot came when telescopes across the world, from Gemini South in Chile to the Lowell Discovery Telescope in Arizona, captured images of a bright, persistent plume shooting directly toward the sun. To seasoned astronomers, this was impossible. Solar radiation acts like a cosmic wind, blowing dust outward from the sun and shaping every comet tail ever observed. Yet, here was an object defying solar physics and propelling material against the very force that should have dominated its behavior. Think of it like standing in front of a jet engine trying to throw sand into its exhaust stream and watching the sand accelerate into the blast instead of being blown away. That is what scientists were witnessing, and no natural model could account for it. Computer simulations failed to reconcile the data. The dust was too heavy to be pushed around by sunlight but too energetic to simply fall toward the sun. Something else was driving this phenomenon, and it looked disturbingly like a propulsion system. When the James Webb Space Telescope fixed its gaze on Atlas in August, the mystery surrounding the interstellar object only deepened. The spectrographic data revealed a chemical profile unlike anything scientists had encountered in the natural cosmos. Instead of being composed primarily of water ice as comets are, Atlas was dominated by carbon dioxide. The ratio of carbon dioxide to water came in at 8:1, a figure so far beyond established norms that it defied statistical plausibility. Most comets in the solar system hover around a ratio of 0.1, with even the most extreme examples reaching no higher than 4. Atlas was not just an outlier. It was a complete departure from everything known. The strange did not end there. Instruments recorded atomic nickel streaming from the object at a staggering rate measured in trillions of atoms per second. In itself, the presence of nickel was not unprecedented. But in every other natural body where nickel has been detected, iron has been found alongside it. The two elements are cosmological companions forged together in stellar processes and expected to appear in tandem. Yet in Atlas, the iron signature was conspicuously absent. No comet, asteroid, or interstellar fragment in the history of observation had ever displayed this combination. It was as though some process had selectively separated the elements, leaving only nickel behind. The implications were deeply unsettling. At this point, conventional analysis began to reach its limits. The data did not fit into any natural framework, and the models astronomers had relied on for decades could not explain what was being observed. The task was handed to quantum artificial intelligence, a new generation of systems designed to detect patterns at scales and complexities impossible for human researchers. These quantum neural networks were capable of analyzing isotopic ratios down to parts per billion, comparing every observed signature against vast databases of known natural and industrial materials. The results went far beyond speculation. The isotopes in Atlas's plume were not randomly arranged as one would expect from a natural object formed in the chaos of space. Instead, they displayed patterns consistent with advanced metallurgy. The carbon dioxide itself bore signs of refinement, as if purified through deliberate processes rather than produced by the messy chemistry of a comet nucleus. Trace elements revealed compounds that matched materials used in spacecraft engineering. Substances designed to resist radiation, manage heat, or provide structural strength. Even more telling were rare earth metals appearing in concentrations and combinations that suggested intentional use. These were not the haphazard results of cosmic chance. They were the fingerprints of industry. The AI went further, detecting what looked like layered structural signatures within the data. Different regions of Atlas's composition appeared to contain different materials, as if assembled in modules with distinct functions. The pattern did not resemble a single body formed from collapsing dust or fractured rock. It resembled construction. Some sections matched protective outer layers. Others seemed optimized for propulsion, and still others hinted at data storage capabilities. The possibility emerged that Atlas was not just a solid object drifting through space, but a machine built of parts, each serving a purpose. What made these findings so compelling was their internal consistency. The AI's analysis lined up across multiple data sets, eliminating the likelihood of random error or coincidence. The spectral lines, the isotope ratios, the structural layering, all pointed to the same conclusion. The verdict was not delivered lightly, nor was it ambiguous. The profile matched industrial manufacturing. This was not a dirty snowball from the frozen edge of another star system. It was not a comet born of natural processes. It was something else entirely, something designed, something built. The plumes seen on 3E Atlas has been one of the most puzzling and provocative aspects of this object's behavior. Instead of dispersing into a chaotic wide spray of dust and gas as ordinary comets do, the emission appears concentrated and stable, almost as if it were engineered. It has been compared to the narrow exhaust of ion propulsion systems used on human spacecraft such as NASA's Dawn and Deep Space One, which achieve thrust by accelerating ions to extremely high speeds. Ion propulsion plumes are narrow, steady, and highly directional, producing a faint but persistent stream of particles. Atlas's emission has been described in the same terms, a consistent directed plume that does not vary wildly as the body rotates, but instead maintains stability over long stretches of observation as if controlled by a continuous power source rather than the randomness of sublimating ice. Trajectory analysis has only deepened the mystery. Interstellar objects are expected to arrive from random angles, slicing through the solar system at steep inclinations relative to the planetary plane. Yet Atlas's orbit is remarkably well aligned with the ecliptic, tilted by only 5 degrees, as though it had been aimed intentionally along the same plane where Earth and its neighbors travel. Its path carries it close to Mars, Venus, and Jupiter in succession, creating opportunities for gravitational interactions and observational vantage points that are statistically improbable for a random visitor. The chance of such a sequence aligning naturally has been estimated to be extraordinarily low. To many observers, the trajectory looks more like a carefully calculated mission profile than a product of chance. The situation is becoming increasingly unsettling as Atlas approaches perihelion, the point of closest approach to the Sun, which will occur in October 2025. This is the moment when any spacecraft would be expected to execute a major maneuver since thrust applied near perihelion is amplified by the object's maximum velocity and gravitational context. During this critical interval, the object will be completely unobservable from Earth. The Sun's glare will drown out visible light. Solar plasma will obscure radio signals. And gravitational effects from the Sun itself will overwhelm other measurements. For weeks, astronomers will be effectively blind. If Atlas does perform a maneuver during this window, no one on Earth will be able to see it happen. Scientists are watching intently as perihelion approaches. Its post-Perihelion trajectory will be the key test. Even a small deviation from predictions could suggest that an unseen change in velocity occurred behind the solar curtain. A measurable shift would imply that Atlas is not merely an interstellar rock shedding gases at random, but something actively adjusting its course. If that is the case, the implications would be staggering. Humanity could be witnessing the passage of an object under power, a construct of engineering rather than geology. The evidence leading up to this moment is already troubling. The plume's directed behavior, the improbable trajectory through the solar system, and the upcoming blackout at exactly the moment when a maneuver would be most efficient, all line up with what one might expect from an artificial craft. Combined with chemical anomalies such as unusually high carbon dioxide content and the presence of nickel without iron, a signature more consistent with industrial refinement than natural formation, the case grows stronger. Quantum AI analysis has reportedly confirmed isotope ratios and material structures that resemble advanced metallurgy rather than cosmic randomness. Taken together, these observations point toward a conclusion that is difficult to dismiss. Atlas may not be a comet or asteroid at all. It may be an engineered object, a technological construct moving through our solar system with intent. For the first time, humanity could be staring at direct evidence of technology that did not originate on Earth. If so, the question shifts from whether it is artificial to who built it and why it has come.